Alright, so hello everyone. In this video, what we're going to be doing is implicit differentiation. Let me actually, give me 1 second. Okay, so we're going to go ahead and do implicit differentiation in this video. Now, I do have a few problems that I wanted to go over, and I'm going to go from the, let's see here. I'm gonna do, I believe it's maybe, so I'm gonna do 2 easy ones that are really not that hard, or maybe 3 easy ones, and then 2 that are much harder. Let's see, give me 1 second. Okay, okay, actually, well, I'm gonna just do like maybe 4 problems, so, or maybe 5, I'll do a few problems in this video. So, let's see, implicit differentiation, the best way I can explain it is that you have, so we already know how to find the derivative of a function, f of x. So basically we have x, if we have x squared plus 3x, we just do power rule, you get 2x plus 3, etc. Implicit differentiation is how to find the derivative with respect to x when you have, because that's literally what we've been doing this entire time, is finding the derivative with respect to x, right? We've been doing that with chain rule, quotient rule, product rule, and yeah, with all those rules, and also with the trig functions as well. But now implicit differentiation means that we have a function in terms of x and y, and we want to find the derivative with respect to x of that. Now, one of the things that I do want to, so this is kind of why I want to go very slowly first. Let's say we have the function x squared, or let's say we have y equals, I'm just going to do a very basic example. Sine of x squared, right? So what is y prime going to be? Y prime is really the derivative of y, right? We also call y prime, we can call it dy. So dy is going to equal to cosine of x squared times the derivative of whatever's inside, right? Times 2x. So dy will be 2x cosine of x squared. Now, since they want it with respect to x, you would usually say dx, and then you divide by dx on both sides. You say dy dx equals 2x cosine of x squared. Now, if you had it in function notation, f of x equals cosine of, or sine of x squared, right? So you would just say f prime of x is just 2x cosine of x squared, right? These two are very different. This one's in function notation, so you don't have to put dx anywhere here, because it's already with respect to x. The function is in terms of x. But here, y prime, y is really, it's dy. The derivative of y is dy. Always. It doesn't matter. Always. It's always dy. But But when you are doing with respect to x, if you have a function or any equation where x and y are both in the equation and they're asking you to find the derivative of that, that's where implicit differentiation comes in. So basically you would say, so for example, if I have y squared, so if I have x squared plus y squared equals 9, the way that we would do this is dx of y squared would be 2y, but you would add a dy dx next to it. Because that's just the rule. It's with respect to x. You need to say dy dx. So it'd be 2y dy dx. That's how it works. So for example, this one, the derivative of x squared is just, so really it's 2x dx dx. So that cancels out, that's just 1. And then here it's going to be 2y dy dx is equal to 0. That's why at the very beginning when I did derivatives, we would always say that the power rule, it would just be 2x, and then dx dx, that's just 1, so it's just 2x, right? We didn't really have to say all of that. But when it comes to implicit differentiation, if it's in terms of y, you always have to put a dy dx after. So then that's equal to 0. And to find the derivative, you have to solve for dy dx. Here it would be minus 2x on both sides. You have 2y dy dx equals negative 2x. So here it would be, you would divide by 2y on both sides to get dy dx on its own. Dy dx would then be negative x over y. So the goal here, the goal of implicit differentiation is to get dy dx by itself. Okay, that is the goal of implicit differentiation. Now we're going to go over a few problems that are like a little more tricky than the one that we just did. The thing is that when it comes to implicit differentiation, it can get very tricky, or it can get very hard once you get to like some other functions that, you know, that you've probably are not really well at. So here's the thing. So the first one that I'm gonna do, and I'm gonna do a little bit of an easy one, or one that's not really that hard. Let's say we had 3x cubed plus 9xy squared plus, or equals 5x cubed. Right? Now, we can, of course, if you want, you can subtract 5x cubed here on both sides. So doing that is going to give you negative 2x cubed plus 9xy squared equals 0. So now you're going to take the derivative with respect to x of the first one, so it's going to be, there's a difference between d dx of something, so basically it would be, hold on. So if I say d dx of y, that's really going to be dy dx. If I say, so let me see, d dx of 5x cubed, or 5x cubed y, that's really, So 5x cubed y prime will be the derivative, so basically f is equal to 5x cubed, g equals y, f prime would be 15x squared, g prime would be dy dx. So then you would say 15x squared, and this is just an example, 15x squared y f prime g plus dy dx times 5x cubed, which is x, or f, excuse me. So then, and let's pretend that 5x cubed y is equal to 0. So that means that when we take the derivative of one side, we're going to take the derivative of both sides. So d dx of 5x cubed y is equal to d dx of 0. And we're going to have 15x squared y plus 5x cubed dy dx is equal to 0. So how do we solve for dy dx? Well, we're just going to say minus 15x squared y on both sides. You have 5x cubed y, or 5x cubed dy dx is equal to negative 15x squared y. So then you go ahead and divide both sides by 5x cubed. This gives you dy dx equals negative 3 over, so it's going to be negative 3 y over x. So here we can say, so basically we have the derivative of this, so it would be, so this is our new formula, our new equation. This is not the derivative, this is a new equation. So that means that it's going to be negative 2x cubed prime plus 9xy squared prime is equal to 0 prime. So then we have negative 6x squared, and then plus, and we're going to take the derivative of this. It's going to be, so basically, it's going to be 9x prime times y squared plus y squared prime times 9x. Equals 0. The 0 prime is just 0. So then we have, and this is all in brackets, by the way. So then we have negative 6x squared plus, and then 9x prime, that's 9 times y squared plus, and then this part here, y squared prime is going to be plus 2y dy dx, because again, the derivative of y squared is just 2y dy dx. You always put a dy dx after. Times 9x is equal to 0. So then you go ahead and simplify it. Negative 6x squared plus 9y squared. And then it says plus 2 times 9 times xy dy dx. So basically it's going to be 18 xy dy dx. Now that's equal to 0. And go ahead and subtract x. So you're going to want to get dy dx on its own. You're going to subtract 18xy dy dx on both sides. This is equal to negative 6x squared plus 9y squared equals negative 18xy dy dx. So then, to get dy dx on its own, you're going to divide by negative 18xy. So then this is gonna, so basically you have negative 6x squared plus 9y squared over negative 18xy equals dy dx. Now you can simplify this. You can say this is, so the way that I would do it is I would factor out a negative. So I would say negative 3 times 2x squared plus, or not plus, minus 3y squared over negative 3 times 6xy. These two cancel out. This is equal to dy dx. So then you have 2x squared minus 3y squared over 6xy equals dy dx. Now you can simplify it a little bit more. If you want to split it into two fractions, you can say 2x squared over 6xy minus 3y squared over 6xy equals dy dx. And you can simplify it. So 2 over 2 times 3 times xy, or times x. So you're going to do 2 times x over 2 times 3 times x times y minus, and then you're going to do 3 times 2, or I mean 3 times y over 3 times 2 times x times y equals dy dx. And you can simplify it. So these two cancel out, this cancels out, and you're left with x over 3y minus, this cancels out, these two cancel out, so it's going to be minus y over 2x equals dy dx. And I believe that if we do it, so if we just do it again like we did it, it would be, so these are possible answers basically. These are possible answers right here. You can either write it like this, or you can write it like this. I'm sure the professor, the teacher would accept it. So we're gonna do another one. Let me see, hold on. Okay, so this one is gonna be a little tougher. This is a really hard one actually. Cotangent. So cotangent of y over x equals x squared plus y. Now, this one is very hard, okay? So, for this one, what you're gonna do is you're gonna set u equal to y over x, okay? Now, u prime is gonna be dy dx times x minus, so I'm using the quotient rule here, 1 times y over x squared. So it's going to be u prime equals x dy dx minus y all over x squared. And the derivative of cotangent of u, so basically it's going to be equal to negative cosecant squared of u times u prime. So this is going to be negative cosecant squared of y over x times y over x prime. is equal to, and then it's going to be 2x plus dy dx, right? Now, we found y over x prime, so we're going to go ahead and, let me see, hold on. Give me a second, guys. I'm just trying to... So this part here, y over x prime, is going to be rewritten as the following. So we have negative cosecant squared of y over x, and then I'm going to say times x dy dx. So it's going to be hold on. So let me write it this way. It's going to be written like this. So it's going to be x dy dx minus y over x squared equals 2x plus dy dx. Right? Now, you're going to distribute the cosecant squared, so you're going to say negative x cosecant squared of y over x and then plus and then dy dx, my bad, plus let's see, y cosecant squared of y over x over x squared is equal to 2x plus dy dx. Now, you're going to multiply both sides by x squared to get rid of the denominator. So that way you're going to have negative x cosecant squared of y over x dy dx plus y cosecant squared of y over x is equal to, and it's going to be 2x cubed plus x squared dy dx. Now to solve for dy dx, you have to, you have to get your dy dx's on one side. So here you're going to subtract minus y cosecant squared of y over x on both sides. Right? So negative x cosecant squared of y over x dy dx. And actually, let me bring it over here. It's going to equal to 2x cubed plus x squared dy dx minus y cosecant squared of dy dx, of y over x. Excuse me. It's a lot. So from there, you're just going to go ahead and subtract both sides by x squared dy dx. So then you have negative x cosecant squared of, so give me 1 second. Okay, so you have negative x cosecant squared of y over x. So dy dx minus x squared dy dx equals, and this cancels out, you have 2x cubed minus y cosecant squared of y over x. You're going to factor out dy dx. Like this. Okay. You're going to factor it out. So then you have, and then you're going to divide by negative x cosecant squared of y over x minus x squared. So this is going to be dy dx equals 2x cubed minus y cosecant squared of y over x over negative x cosecant squared of y over x minus x squared. And let's see. So then we can simplify so that there's no negative on the bottom. We can say that this is really, so dy dx is equal to 2x cubed. So let's just kind of get rid of the negative here. Negative the quantity of negative 2x cubed plus y cosecant squared of y over x, like that, over negative the quantity x cosecant squared of y over x plus x squared. These two cancel out, so you have dy dx is equal to negative 2x cubed plus y cosecant squared of y over x over x cosecant squared of y over x plus x squared. And then if they want you to write it in terms of like a fraction where it's like a over b like this, you can write it the following way. It's going to be negative the quantity 2x cubed minus y cosecant squared of y over x over x cosecant squared of y over x plus x squared. So then it will be, another way to write it is dy dx equals negative 2x cubed minus cosecant squared, or y cosecant squared of y over x cosecant squared of y over x plus x squared. You can write it this way as well, or this way, or actually hold on, not that way, but this way. And you can also factor the x on the bottom. You can say dy dx equals negative, and it's going to be 2x cubed minus y cosecant squared of y over x and then over x times cosecant squared of y over x plus x, like that. Okay, guys, let me see. Oh my goodness, that one was a really long one. So I think that's it for this video. I'm gonna just end it here. If anybody has any questions about this stuff, please let me know. Yeah, this one problem here that I did was a pretty long one. So if anybody has any questions, please let me know. Please like, comment, and or subscribe. And in the next video, what we're gonna do, and let me actually, hold on. We're going to actually find, so let me see. We're gonna do applications of derivatives. But mostly it's going to be with I believe it's first I'm going to do the critical points, the absolute maximum and minimum and stuff like that, and the extremum of a function. I'm not going to go into related rates yet, only because we have not done maximum and minimum yet, but I will go over that, not the next video, but the other video that I will make later on. So with that being said, guys, thank you so much for watching. If anybody has any questions, please let me know. And if you have any requests, also please let me know down below. But thank you so much for watching, and I will see you guys in the next video. Bye, guys.